Hi, everybody. Welcome back from the break. I hope everyone had a great lunch. Welcome to our session. Thank you so much for joining. And my name is Gina Lee, and I am a UVA alum, class of 2019. And I'm here with four others of my IBM colleagues who are all UVA alumni as well. And we're very excited to come back and engage with the UVA community. So I will be starting the presentation. And I hope everyone is staying safe and healthy during this time. So our session is called Trust and Transparency, Preventing Bias in AI. And throughout our session, if you have any questions, get on Twitter and using the hashtag 2020 Charlottesville Women in Data Science, WIDS, you can ask any questions related to data science or career-related questions. Any questions are welcome throughout. And at the end of our session, we'll do a Q&A as well. So I would just like to introduce myself again and the rest of the team. My name is Gina Lee, and I graduated May 2019 with BA in American Government and Social Entrepreneurship minor. And I'm currently the Solution Sales Specialist at IBM, and I'll be transferring over to a Federal Data and AI team April 1st, which is next Thursday. And Jessica Emmons is an IBM Technical Solutions Specialist, and she's also class of 2019 with BS in Computer Science and Engineering Business minor. Marissa Patrick is an IBM Power Technical Specialist in Federal Systems, working specifically with Health and Human Services and Treasury. And Marissa is class of 2018 with BS in Biomedical Engineering. Haley Hadaway is an IBM data scientist, and she's in the Data and AI Expert Labs and Learning for North America Government, and she's class of 2018 with BA in Cognitive Science and Bioethics minor. And last but not least, Nikita Mecca is an IBM Technical Specialist for Data and AI and Public Healthcare and Life Sciences, and she's class of 2018 with BS in Biomedical Engineering. So the five of us have been working on this session together for the past month or so, and we're very happy to be back and give back to the community. So for our session today, we'll be introducing the concepts of data science and AI. I know the audience today, some of us are very familiar with data science, others may be hearing about data science for the first time. So we just want to set a common understanding of data science and AI. And then we'll go into ethics in data science and AI and just talk about IBM's positioning as well as positioning of other companies that are looking to promote ethics in data science. And then we'll go through a case study demonstration to see how identifying bias and mitigating bias comes to life by an example. And then we'll wrap up and open up for a panel discussion where we'll answer career-related or data science-related questions, and that will be the engagement portion. So I just want to start off with a quote from our CEO, Ginni Rometty, just to set the tone of what AI really is. And Ginni says, some people call this artificial intelligence, but the reality is technology will enhance us. So instead of artificial intelligence, I think we'll augment our intelligence. And I think this quote is very significant because it speaks to how AI isn't aiming to replace human intelligence, but it's simply trying to add on to our intelligence that we already have and complement it. And whatever human inconsistencies that we may have, AI works to mitigate that, and which will lead to better decision making of all stakeholders and which will make the workforce more efficient. So this is just a tone that we want to set throughout our session today. So what is data science, you may ask? And data science is a discipline where there is not one clear answer of what it is, but just to set a common understanding, I would first like to start off with a short clip.
Data science is a process, not an event. It is the process of using data to understand different things, to understand the world.
For me, is when you have a model or a hypothesis of a problem and you try to validate that hypothesis or model with your data.
Data science is the art of uncovering the insights and trends that are hiding behind data.
It's when you translate data into a story, so use storytelling to generate insights. And with these insights, you can make strategic choices for a company or an institution.
Data science is a field about processes and systems to extract data from various forms, whether it is an unstructured or structured form.
Data science is the study of data, like biological sciences are the study of biology, physical sciences, it's the study of physical reactions. Data is real, data has real properties, and we need to study them if we're going to work on them.
Data science involves data and some science. The definition or the name came up in the 80s and 90s when some professors were looking into the statistics curriculum, and they thought it would be better to call it data science. But what is data science? I see data science as one's attempt to work with data to find answers to questions that they are exploring. In a nutshell, it's more about data than it is about science. If you have data and you have curiosity and you're working with data and you're manipulating it, you're exploring it, the very exercise of going through, analyzing data, trying to get some answers from it is data science. Data science is relevant today because we have tons of data available. We used to worry about lack of data, now we have a data deluge. In the past we didn't have algorithms, now we have algorithms. In the past the software was expensive, now it's open source and free. In the past we couldn't store large amounts of data, now for a fraction of a cost we can have gazillions of data sets for very low cost. So the tools to work with data, the very availability of data, and the ability to store and analyze data, it's all cheap, it's all available, it's all ubiquitous, it's here. There's never been a better time to be a data scientist.
Thank you. So essentially, data science is the means of capturing data, maintaining the data in data warehouses, processing the data, analyzing the data. For example, there can be predictive analytics where not only can we give prescriptive solutions to problems or decisions, the AI model will be able to predict what kind of questions or concerns people may have, or what kind of maintenance issues for a car, for example, would arise. And then we'll be able to communicate the data with the dashboard, charts and graphs where we can show trends in data and what we can learn from it. But that is not to say AI is perfect. There are many challenges with AI because AI is as good as the kind of data that we put in. And as humans, we have conscious and unconscious bias that we are faced with, whether it be ideological, gender, or racial bias. And IBM research shows that there are more than 180 human biases that have been defined and classified, and any one of which can affect how we make decisions. For example, in our demonstration, we'll show how gender bias can play into whether or not you can whether or not you can get a loan, and if yes, how much loan you can get. And biases find their way into the AI systems we design and are used to make decisions by many, from governments to businesses, whether it be state or local governments, all the way to federal government, and then businesses like banks. These large institutions are using the data we put in order to make decisions. So not only is bias in data affecting these stakeholders, but it's these stakeholders and decision makers, it's also affecting the general public. And so bad data used to train AI can contain implicit racial, gender, or ideological biases. And this is something that we're looking to mitigate as a company. And bias in AI systems could erode trust between humans and machines that learn. So with AI, that shows human inconsistencies and aims to better human decision making. Through AI, we're able to see the implicit bias we normally wouldn't notice in our day-to-day lives. And hopefully, by mitigating bias in data science, we're able to be more aware of these biases and come out more impartial and more egalitarian in return as humans and as decision makers. And then I'll hand it off to Haley now to talk about the 5 different ethical focuses of data science and AI that IBM has.
Great, thanks, Gina. So now that we've gone through a little bit of an introduction on data science and AI, we wanted to spend some time on IBM's approach to ethics. So this slide is a summary of a document that IBM published titled Everyday Ethics for Artificial Intelligence. It is meant to be used as a tool for those developing AI to avoid tech-centric design of AI systems and instead consider the widespread impact that these systems have on actual people. So this document outlines IBM's 5 areas of ethical focus that align with some of the challenges that Gina just discussed. The first area you see here is accountability. So while data science and AI use algorithms to make decisions, it's essential to remember that it's humans that create those algorithms. The biases we have that Gina mentioned earlier can easily be infused into any algorithm that we design. So IBM's stance is that every person involved in the creation of AI at any step is accountable for considering the system's impact in the world, as are the companies invested in its development. The second area here is value alignment, meaning that AI should be designed to align with the norms and values of your end user group in mind. At IBM, as an international business, this includes consideration of things like varying cultural norms that we don't always have to consider, but are really important. The third and fourth areas are particularly relevant to our demonstration today: explainability and fairness. Many of you may have heard the term black box with reference to technology systems. This is a major issue in data science and AI. If we know the inputs and outputs of an algorithm, but we can't easily understand how the output was produced, we haven't really developed a trusted algorithm. Any decisions made by AI should be explainable so that users know what decisions are made and why they were made. Similarly, we need to be aware of the biases that go with human creation of data science algorithms. So IBM's stance on fairness is that it is the role of a responsible team to minimize algorithmic bias through ongoing research and data collection, and that needs to be representative of a diverse population. The last area here is user data rights. This, of course, has been an increasingly relevant issue. I'm sure most of us remember Facebook's heavy criticism and even legal investigation over sharing users' data. And this is, of course, an ethical concern, but for business, it's also a regulatory concern. Laws like the EU's General Data Protection Regulation, or GDPR, make it all the more important for businesses to make sure they remain compliant. So moving to this next slide, in addition to 5 areas of ethical focus, IBM has also published 3 principles for trust and transparency in data science and AI. These closely tie to the themes that we just went over, but one of these is particularly relevant to our case study and demonstration. The first principle states that the purpose of AI is to augment, not replace, human intelligence. As Gina's quote from Ginni Rometty implied, AI is about bringing intelligence and expertise to the hands of the entire workforce. So there are a lot of fears, there have been a lot of fears with the general public about machines replacing people, replacing jobs and things like that. And the point of AI is not to replace those people. It's to make sure that the common knowledge base is brought to everyone in the workforce, regardless of position. The second principle is that data and insights belong to their creator. IBM's stance is that users of an AI system should retain complete ownership of their data. So for example, we could use a customer's data to train a chatbot. But if we begin similar work with another client in the same industry, we can't use that same data to make client 2's chatbot system better. Alongside that, we also believe that data security and protection are absolutely essential and need to be infused throughout an AI or data science system. The third principle highlighted on this slide is that new technology, including AI systems, must be transparent and explainable. This is a really common theme throughout this presentation, but for the public to trust AI, it must be transparent. Technology companies need to be clear about who trains their AI systems, what data was used in training, and most importantly, what went into their algorithms' recommendations. If we are to use AI to help make important decisions, it must be explainable. Next, we have a video that gives a little bit more insight into why this is also important. Great. So to conclude this section on IBM's approach to data science and AI ethics, this last slide is just a list of unconscious biases that many of us are likely guilty of on a day-to-day basis. I won't go through all of them, but I thought that this visual made it pretty clear how important it is to consider your own biases when building technology that will have an impact on the world. Just reading this top row, a shortcut bias like, I don't have the time or energy to think about this, a bias like, I know I'm wrong sometimes, but I'm right about this, or we contributed the most, they weren't very cooperative. Those are probably things that you've said before or something like something that you've said before that is a bias. Some of the common ones on this slide are stereotyping, which I'm sure we're all familiar with, as well as confirmation bias, which is the tendency to focus on information that confirms your own beliefs, or in-group out-group bias, which is our tendency to favor members of our own in-group rather than members outside of our in-group. So again, it's really important to remember that if we have all of these biases, those are going into the technologies that we create. AI seems like magic, data science seems like magic, but it's really not. It's an extension of our human cognition, and it's created by us as data scientists. So these are all really important to keep in mind. IBM's stance is just an example of how ethics is handled in industry, but it's definitely one that I personally am proud of. And for those of us working with government clients, it's also very important to our work day to day. So now that we've gone over data science in general and IBM's stance on ethics in data science and AI, I'm going to pass it off to my colleagues Marissa and Jess to take us through a case study and demonstration that will show this in action.
Thanks, Haley. So now that we've discussed different types of bias and how they might manifest in our daily lives, I'd like to explore a few recent examples of bias in data science and AI. So on this slide, I've included 4 headlines from the past few years that many of you may recognize. So these and other similar headlines highlight unfairness in AI models used by organizations ranging from recruiting tools and search engines to crime prediction algorithms. And while organizations often don't intend for the tools they create to be biased, it's just an unfortunate reality that we live in because people and data are biased. And as a result, that bias creeps into models that we would otherwise expect to be objective. So I'd like to use this last headline about unfairness in credit limits offered to women that was just from a few months ago to further concentrate on the financial industry, which will be the main focus of our case study demonstration. Gina, next slide, please. So I'd like to continue providing a little bit of context with this slide. So let's say I would like to buy a house and I apply for a mortgage. I provide the bank with my personal and financial information, and then they get back to me saying that I've been denied. So in this situation, the bank is required by the Consumer Financial Protection Bureau to explain why I've been denied that loan. So maybe I've missed a lot of credit card payments because I've been shopping a lot and not paying my bills, or I don't have enough savings. And so this isn't unusual. In the upper right, I included a statistic just to explain a little bit about the scope of this. But in 2018, approximately 10% of conventional mortgage applicants were denied. So this isn't a trivial number of people. So what does this have to do with bias in data science? Traditionally, lenders use a variety of data to make this assessment, including personal and financial information. And those banks are increasingly leveraging data science and automation to contribute to that individual's risk assessment, kind of similar to the way that they made that assessment of me when I applied for a mortgage. So, but they of course still need to be able to explain these decisions for both ethical and regulatory reasons. And so by requiring that these models be transparent, like Haley said, this is a way of ensuring that financial institutions treat everyone fairly regardless of age, gender, or race. And so next, Jess will explain more about the case study that we'll use to further explore bias in data science.
Like Marissa said, unexpected correlations arise when lenders turn to wider and riskier populations, which can introduce bias when a bank tries to assess an individual's credit risk. This can become especially problematic when lenders try to automate this task with a machine learning model. To show you an example of this problem in action, today we built a machine learning model based on evaluating credit risk. The data we use to build the model includes loan duration, payment history, and other information included on this slide. The model aims to assess, based on the data provided, how likely an individual is to repay the loan provided by the bank. basically whether they pose a credit risk. Right now, Marissa and I will show you a way to build a tool to assess the quality and fairness of these predictions based on standards for gender. During this demonstration, we will use IBM Watson OpenScale, a tool specifically developed for the purpose of mitigating bias in AI models. Other tools like Google What If or Python's FairML library don't have easy product logos, so they weren't put on the slide, but those tools, along with similar tools on this page, have a similar use to OpenScale. We chose OpenScale today because it has a streamlined interface which aligns with our purpose. In this demonstration, Marissa and I will go through the 4 steps listed here. We will check the quality of the model, check the fairness of the model, develop and analyze a debiasing scheme, and look at the specifics behind an individual transaction. In this demonstration, we will first be looking at model quality using the area under the ROC curve. Simply, we are measuring how much our model is capable of distinguishing between classes. Previous slide, Gina. We want to be able to determine if the quality of our model meets a 90% threshold based on gender bias standards. Okay, now next slide, Gina. This is the main page of our OpenScale tool. As you can see, we have it monitoring our credit risk model. To determine the quality of a model, you need to provide it with decisions labeled by a human as feedback. If we click the menu on this model and then click Configure Monitors, we can then navigate to a page where we can click Endpoints and then Upload Feedback, where we can upload feedback data. We previously made a data feedback CSV for this presentation that is delimited by commas. This CSV is just a sample of information on individuals that could apply for credit, or a person has decided whether they are risk or no risk. Once the feedback data is uploaded, we can navigate back to the main page to begin checking if our model is of the desired quality. Once again, we click on the model menu, but this time we click View Details to bring us to the model analysis dashboard. This dashboard is an area where we can click under the ROC, as that is one of the main measures of quality. If we click Check Quality Now, it will calculate the area under the ROC as 0.74, which is 0.616 below our 90% threshold. This means that we will have to add more data and continue training the model until we receive that desired model quality. If we click the blue dot, we can see the calculated quality metrics, and we can use that information to make future decisions about our model. Finally, if we navigate back to the main page, it shows our recent quality check and score. This process can be repeated until we have gotten the model to the desired quality. Next, we will be checking the fairness of the model. A fairness metric is a ratio of the percent of the group we want to monitor that is labeled as favorably over the percent of the group we expect to be treated fairly that were labeled as fairly. In this specific instance, it's the percent of females that were labeled as no risk over the percent of males that were labeled as no risk. We want our fairness to be at 95% based on gender standards. To start, we need to give the model some data to classify. Here we have already copied some sample data on individuals applying for credit in JSON format and navigated to the testing tab of our deployed model. Pasting the data into this box and clicking Predict asks the model to classify each of the individuals as no risk or as risk. Navigating back to OpenScale, our debiasing tool, we see that our model is still being monitored, so OpenScale has access to the tests we just performed. Once again, clicking the model menu and then View Details will bring us to the model analysis board. This page automatically opens on the tab focused on the fairness metrics for sex, so we'll focus on that in this example. Clicking Check Fairness Now will check the outcomes of the previous test and determine the fairness metrics for those outcomes. After the fairness check, it was revealed that the model had only 93% fairness in terms of sex. This is 2% below the threshold so an alert is triggered by the application. This alert tells us, the data scientists, that some work will have to be done in order to make this model usable and ethical. Very quickly, we were able to determine that this model wasn't fair in terms of sex, so we need to do more work.
Okay, so thanks, Jess, for those beginning 2 videos. So I will continue with the second half of our case study demo. So what you'll see next is we're going to take a look at the gender bias in this model based on the entire population as defined by the original data set that Jess discussed, and then we'll apply a debiasing scheme to make this model fair for both men and women. So by clicking on that blue data point on the left, on the blue data point on the right, we can delve deeper into the gender bias in this model. And so on the next page, what you'll see is that the group on the left representing females is highlighted in red. And so this indicates that bias was detected. For both males and females, we can see the breakdown of those considered to be risky in the light green on the top and those that were not in the dark green on the bottom. And by hovering over the bar chart, we can see how 39 of 200 male applicants were considered to be risky versus the 50 of 200 female applicants that were considered risky. So this shows us that there's a discrepancy between those two groups. Next, by clicking on the debiased option at the top, we can apply a debiasing scheme that reduces that bias to 0. So now that we see the riskiness assessment for males and females is approximately the same when observing the number of risks for each group. Last, the endpoint for invoking the debiasing algorithm can be obtained by clicking on View Debiased Endpoint. This means that you can insert this code into an application to proactively debias models in several different programming languages. And of course, while we'd like to avoid bias models altogether by instituting fair practices and using cleaner data, this is a great option too. So now that we've debiased our model, let's move on to see it in action. So next, we'll take a look at a specific transaction to better understand how the assessment was made that someone is risky. So we'll first click on the blue View Transactions button, and then we're taken to a new page. So on the right, what you'll see are some metrics comparing our biased and debiased models and how our debiased model has more favorable outcomes. On the left are individual transactions or predictions that model made. So I'll pick the first transaction classified as risky and click on Explain. So we're taken to a page that displays the confidence score for having no risk, represented by the gray bar on the left, or being risky, represented by the blue bar on the right. So we see that the model has a slightly higher confidence score that the individual is risky of 50.37%. So if we continue moving down the page, we can delve more deeply into why the assessment was made that this person is a credit risk. So on the right side, we can see factors contributing to risk confidence level. Ranking from most influential to least, we see that loan duration, checking account status, employment duration, residence duration, installment percent, and telephone ownership are all important factors in determining that this applicant is risky. So I hope what you've seen is that this is a really powerful way of exploring how models make predictions so we can validate whether a model is doing what we expect it to and that it's treating everyone fairly. So next, I'd like to wrap us up and review what we just saw. So we started with the model to assess credit risk and then identified bias based on age and gender using those predetermined standards that Jess talked about. So we reviewed the bias and then we removed the bias, and then reviewed a specific example. So ultimately, this shows us how we can better identify and mitigate bias in AI models. And while we just explored how we can debias a model, that doesn't mean that all people will be deemed low risk. As we saw, some applicants may still be considered credit risks. So the purpose of mitigating bias is to ensure that this assessment is based solely on financial data and not certain personal attributes like gender, age, or race. And so in this way, businesses can employ fair and equitable practices. So next, on to Nikita to share some additional resources and discuss why this is important.
Thank you, Marissa and Jess, for walking us through that demo. We wanted to leave you all with some additional resources that you could use, and we included a link to this open skill lab that you just saw, which you can try out for free on the IBM Cloud. If you're interested in learning more about any of our other AI tools or data science in general, you can also check out these other links. IBM offers countless classes through our badge program that are industry recognized. I know that we all are constantly taking new classes, and it's a great way to learn about up and coming areas and tools that people are using. Most, if not all, of these resources are free. So now that you've seen how bias can be embedded in mortgage applications, you should also think about why this matters. It may be somewhat easy to see why ethically bias is something that should be mitigated. I mean, it's clearly not fair to be using biased predictive models that discriminate against women. But it's important to realize that it goes beyond just the concept of ethics. There are important regulatory, economic, and cultural consequences to this type of bias. With regards to regulations, many industries are starting to set guidelines for how there must be trust and transparency within AI applications. If these rules aren't followed, then organizations can face serious consequences. And in our case, banks would have been required to explain why they were denied a loan. And here we were literally having people denied loans just because of the fact that they were female. This isn't only within specific industries like financial services, but there's actually federal legislation, like Haley mentioned earlier, that requires organizations to audit their algorithms. Organizations can take advantage of technologies like OpenScale to comply. As for the economic impact of bias, think about the consequences of allowing this type of mortgage application model to be used. There would be women who would be unfairly denied mortgages based solely on their gender. That would disenfranchise these women from becoming homeowners. Because of this faulty algorithm, we would be denying women of their ability to purchase real estate, which could be detrimental to their livelihood and the economy as a whole. That ties into the cultural impact as well. This would all perpetuate disadvantages that women often face, and this faulty model would be a barrier to women's economic prosperity. It may be obvious that something should be done about this. The problem is that ethics is not an exact science. It takes people of diverse backgrounds and perspectives to mitigate things like bias. That involves defining what bias looks like and what the best ways are to fix these problems. If a group of people are working on algorithms that doesn't have that type of diversity within them, it's easier to overlook the needs of anyone who's not in the majority. That's why we are relying on you as future contributors to data science and AI to think about these things and intentionally work to stop the bias. Right now, I want you to start thinking about everything that we've talked about today and how you can use this information in the future. You all might be at different points in your data science journey and may have very different backgrounds. I want you to pick an industry that you are interested in and how ethics would be important to that industry. Where do you imagine there could be bias in currently used data science applications? Use this thought exercise to start getting into the habit of having these types of considerations in your future projects. We also wanted to briefly acknowledge the current situation that the world is facing with COVID-19 and mention some of the ways that a technology company like IBM is contributing to the fight. This is an example of corporate responsibility where it is so essential that we all help in the ways that we can. As a company that has an extensive skill set and the technology needed to take advantage of data, I'm proud to say that there are many initiatives that we have started. The biggest initiative that we have is the launch of the COVID-19 High Performance Computing Consortium. And we're working with the US federal government and other companies to research the creation of treatments and vaccines. Our Summit supercomputer is the world's most powerful computer, and it has already identified 77 or so compounds that show potential for impairing the spread to healthy cells. Beyond that, we've been creating tools to track the spread, like on the Weather Channel app, and have organized our Call for Code competition to encourage people to work on other solutions that we need at this time. We're also providing solutions to clinicians, hospitals, governments, and many other groups that are being heavily impacted by this. a few of us on the team are actually working on our virtual agent that is pre-trained to answer questions about COVID-19. And we are offering this for free use to help offload call centers and help answer commonly asked questions. Anyways, it's amazing to see how everyone is stepping up to the plate to help get us through this. And thank you to everyone who has been submitting questions using the hashtag. And we will now have Arlen come on and help moderate some of the questions that you have from Twitter.
Great, thank you so much, Nikita. Thank you all for such a fantastic presentation. I want to invite everyone to please do use the hashtag 2020 Charlottesville WIDS to ask any questions that you have of our IBM presenters. And while hopefully those questions come flowing in, we've got a little bit of time to do a Q&A. I thought I might start maybe by asking a question. And maybe I'll start by asking you, Nikita, and then any of the rest of you that want to chime in as well, please help yourselves. My question is about kind of what you were talking about last, about why this is important, right? And really thinking about the policy implications of what it is that you guys are doing. And so I would ask, what do you think is the role of a data scientist in exploring the policy implications? And how do you feel like a data scientist can or should insert themselves into that team? And what have you used in your work to really think about that policy implication?
Yeah, I can get started with this, but anyone else can feel free to jump on. So I feel like in the world that we live in, there's just so much data available, and it wouldn't be beneficial if we didn't take advantage of that data. And so data scientists really need to take the initiative to think of ways that our data can be used to help and contribute to the greater good. And I know with regards to policy, there is a lot of restrictions there in terms of what can be accomplished. But I think we do have those kind of guidelines where from the government level as well as within our own industries, that we should be able to use this data and bring it out to the public in ways that we can, if that makes sense. I know I had mentioned with our chatbots that some of us are working on for COVID-19 specifically. It's very difficult for organizations to be handling the influx of calls that they're getting. There's people who are wondering, like, are my schools open? Or can I go in and renew my license right now? There's just so much information that's not known, and websites aren't being updated for that type of information. So we can really take advantage of the technology that we have in order to leave the workers to deal with the more important work versus answering those more commonly asked questions. So we can kind of help with that. I don't know if anyone else wanted to add to that.
Yeah, I would just say I think that many of us have worked in the federal space. And so from the policy standpoint, a lot of the discussion at conferences, federal conferences and things, is about how industry's use of technology can sometimes really drive how the government implements technology. Government doesn't want to be a guinea pig for new technologies. They have to have things that are trusted in that work because they need the trust of the people. So I do think the ways that in or out of federal, the ways that large technology companies implement data science with any client does drive policy and does drive how the government implements technology. So I think that's one interesting thing. And then the only other thing I'd say is that IBM tends to take a really standards-based approach that often is tied with our use of open source and partnering with other technology companies. But that can also be things like the consortium that Nikita was just talking about that are kind of part of the way that we like to implement new technologies that drive industry standards, and I think in turn, again, drive that policy as well. So.
Great, thank you. And it's exciting to see how many of you guys are working in the government space. I think that it's a world that's thinking about bias in very, very real ways, and it's very important as well. So maybe to throw it open to maybe a little more general question, are there areas of data science, either technical or conceptual, that excite you about the opportunities moving forward in the work that you guys have been doing?
We talked a little bit about this this morning as well. I know that a couple of us have been really excited about new projects we're working on, and we've all recently transitioned to new teams, which has been awesome. I'd say what has interested me most so far is the combination of IoT and data science, which they obviously go really hand in hand, but using different sensor data and creating data fusion to be able to have full context of, be it a city or highways or a battlefield. I mean, there are just a number of different applications for acoustic data and even vibrations in the ground, visual recognition, which I know Marissa has worked a lot on. That's probably been the most exciting for me.
Yeah, and I'll just jump in on that to piggyback off of what Haley's saying is that to me, especially coming from a biomedical engineering background like Nikita, actually, I'm always really excited to see like the medical applications of data science. And so something that my customers are working on a lot and something that I work on is how can we better use data science and AI to address the medical needs of a community. So of course, COVID-19 is one of those examples, but also for providing more holistic medicine. Of course, there's a great example of how data science can be applied to better understand an entire population and the progression of a disease. So I would say that, there are so many different medical applications for data science and so many areas in which, of course, we can improve treatments and better understand patients. But of course, that policy piece definitely feeds into that.
Great. Well, maybe I'll go off of something that you were saying there, Haley, about IoT, which I think is absolutely an exciting space that actually certainly could have implications in the biomedical sphere as we start thinking about, all of our devices and all of the data that we're collecting on ourselves on a daily basis. But since your presentation was on bias, have you, and I know perhaps you haven't done a whole lot of work in the IoT space yet, and maybe that's a growth area for you, but have you started to think about the bias related to the actual devices that are collecting the data and who actually has access to the devices themselves, and who is doing things like geotagging or not, for instance, on certain social media and things like that, and how you might begin to think about bias in terms of the way that you're considering IoT data.
I'm sure I've had some hands-on experience there. I had a client that was using visual recognition on edge devices, which is really exciting and very cool. And it was a federal client, and it was actually really encouraging to hear the response from not technologists, but the people who would actually be the end users of these devices. And almost all of them, because this would be something that would be international, were concerned about the bias that would go along with visual recognition of whatever objects or whatever people they were trying to identify. And it would be really hard, obviously, to train algorithms to be able to accurately and without bias identify things globally across countries and cultural norms and different ways of dressing and things like that. So it's definitely something that's on everyone's mind. And in the federal government, my experience at least has been that it's not just on the technologists' minds, it's on the end users' minds too, which is encouraging and exciting, but definitely an area we don't have all the answers, I don't think, yet on how to implement technology like this in a way that is completely fair and unbiased to everyone. And I don't know, I think it might be a while before we get to that point. But what we talked about today is one example of how we might mitigate some of that. And there's definitely some work to do, like you said, with actual end users and how that kind of thing would be regulated.
Yeah, and I would just add to that there's obviously the problem of data collection and the types of data that we're using. And that can be a little bit more difficult to control. You wouldn't really be able to use a tool like this as easily in order to fix those types of issues. And so I think going back to our presentation, it's just that frame of mind that you have of your data scientists and whoever's collecting the data, and making sure that you are representative of the global population of whatever application you're using, and actually considering those things when you're doing the work. It can be easy to take shortcuts and collect whatever is most, like, the easiest to collect, but we should really be intentional about the ways we're doing that.
Great. And perhaps the most important question, we are thrilled to see 5 fantastic, successful who's, women working in the field. And we'd love to hear a little bit about how your time and experience at UVA prepared you for the work that you're doing. And maybe if you want to mention a little bit, I know I can't remember who it was in the presentation, said something about you guys are continuing to learn and all of that kind of stuff. So, what about your experience at UVA? You come from a variety of backgrounds, which is amazing because data science is truly a team sport that involves people from all kinds of backgrounds. But what prepared you for what you're doing, and what are you doing to stay on top of everything? Maybe Jessica, did you want to go first?
Sure. Gina and I are both in a training program currently at IBM. So what you were saying about us constantly learning is very true for Gina and I. And what's interesting about IBM, because it is this place that we're constantly learning, and a lot of our managers like to call it kind of a drinking from a fire hose, because that's what you need to do to be able to bring value to your clients. And the great thing about UVA that prepared me specifically for this position is I think UVA is an environment like that. There's a lot of different sources of information at UVA, and I know everyone on this call came from a different part of the university, whether it's eSchool or arts and sciences, and participated in different activities. So really just taking in everything that can be offered by a university of this size and stature has just been very helpful to prepare me to constantly be flexible and be interested in new things. So I know Gina might want to say something.
Yeah, and just adding on to that, I mean, I come from the Department of Politics at UVA, and I was a social entrepreneurship minor. And honestly, I couldn't imagine working for IBM during my undergrad years, but my background and my education from UVA is helping me to know how to effectively work with federal government clients. And it really set the tone for how I can build my career. And in social entrepreneurship, I learned about how technology is implemented to help state and local governments, healthcare providers, and other societal problems in this world. And that really drove my passion for learning more about data science. And I think UVA, with its new data science program, it offers so many learning opportunities. But going forward, I'm doing continuous learning through IBM, but through other outlets, just continuous learning, mostly online, going through different modules and trainings. So it's been a really great learning experience so far.
Great. So I had a question come in here. So moving forward, especially with the ethical framework that you guys presented, does this mean that IBM will be providing more transparent documentation on Watson services?
Yeah, I can start with that. I know that has been a big initiative because black boxes in data science don't really go together. And I know we have been called out for that, but we are one of the largest contributors to the open source community, and we are trying to implement those types of tooling into our Watson offerings. And I would say that they are making that initiative to be more transparent in the future.
Great. And I think that it's an exciting opportunity for you guys to really be on the forefront of this moving forward. So again, we are really excited to have you guys here. We wish we'd had the opportunity to bring you back to Charlottesville. And so we hope that you will get a chance to come back down and visit us soon. We'll invite you to come down after we're all living much more normal lives again, and come down and see us at the School of Data Science. We're really excited to get the chance to meet you guys in person as well. I will give you the opportunity for closing thoughts, but I think that it's probably all of our questions for now, and we'll take a short break. Did any of you have any additional thoughts that you wanted to say before we close out?
So, I mean, I would just say I really appreciate the opportunity to be able to speak. It is sad that we weren't able to come down to Charlottesville and see everyone in person, but I'm really glad that UVA is making such a great initiative in the data science field with the new school and whatnot. It's unfortunate that we didn't get to attend those types of courses and whatnot, but it's great that future students are able to really learn and contribute in the future. So thank you so much for having us.
Yeah, and I know, oh, sorry. I know this event is annual, so maybe we would love to stay involved and get updates on how School of Data Science is doing, and we would love to come back. Thanks for having us.
Absolutely, that's what I was going to say. We're sorry also that when you guys were students that that we weren't up and running just yet, but believe me, we will be engaging with you and looking forward to opportunities to stay connected. So thank you so much, not only for your presentation, but the amazing work that you're doing in the field. And we invite you to stay engaged with the community. Please, pay attention to the rest of our programming today, engage with folks on social media, and we'll have your stuff posted and feel free to share it. So thank you so much. And for our audience, we're going to take a quick break here, and we'll be back with our leaders panel, which starts at 2 o'clock. Thanks so much.